all these seals have a shelf life. Okay. So you get the curing compounds these days. I think they have a definite shelf life. I don't know how long they last. But anything like silane coating, silane is a bad chemical now to use, but any other chemical coating like that has a shelf life. They last 5 years, 7 years, 10 years. But that's enough for you to get your concrete to be in a very good state. And coating these with silane doesn't cost you that much in the long run. So try that. Okay, so I'll leave that to you to do it, and then if you bring it tomorrow, you can have a chat with me. Tomorrow I'll focus mostly on case studies. So a copy of the slides already in your note pack, but you will get it. So we're now going into complementary areas. Okay, complementary in the sense these are skills and techniques that you can use to sell your ideas. Okay, in order to say anything holistic, in order to sell anything holistic, you need to have the right tools to tell them. Okay, so initial cost or initial impact, whether that's initial carbon dioxide impact of the mix design, is not the right tool to sell the product. So you need to have techniques that will last and that will give you the picture of the 50 or 100 years time. Okay. So that's why we often use the word life cycle or service life or whole life. These are three words that we can use interchangeable. So LCC refers to life cycle costing, where you're taking decision based on the whole life of the intended life of that structure. The intended life could be 25 years, could be 50 years, it could be 5 years. Very often for structures, it could be 100 years. In the UK sector, it's for bridges should be 120 years. The main non-changeable parts of a bridge should be 120 years defined. The non-changeable part doesn't apply to scaffolding, to handrails, the surfacing. They're all shorter service life structures. But the main beam, the culverts, the piers and everything. Okay. They're now even agreeing that if you have a bridge and the pier stems can be 120 years and the bridge deck can be 50 years. Knowing that our technology is there, we can lift the bridge deck and put a new bridge deck in. That's not impossible, it's easy done. At the moment they use hydraulic jacks to lift the bridge to change the bearings in it, so it's really not a complicated technology anymore. So it's up to you to define what is service life. Very often client will tell, I want a service life of certain years. And these tools help you to predict things and to expand things in that spectrum so that you can use that as a selling point. To get the idea, so that's the code that you can use. It's an ISO code, so you should be able to download, those who have access to ISO. Part 5 talks about life cycle costing. They do give examples, so you can obviously learn from the examples. But I'm going to introduce the concept to you. That's all the luxury of time we have. And I'm going to tell you what factors to watch out for. Yeah? Through an example. So you are being made responsible by your family to decide what light bulb should be placed in your bedroom or your living room. So you have a choice. CFL or tungsten bulb. Are you going for CFL? Why?
Save current and life is long.
So you're talking two things here. You're talking about service life, okay, and you're talking about savings during that service life. Okay, can you quantify it? Have you ever quantified it? Okay, we're going to do that in a minute. What are the other things I need to be aware of? So, too many information. So let's filter it down. Service life. operational economy. I lost it. The energy savings. And what else? Yeah. Mainly that's the factor, isn't it? Okay. And what else? Efficiency, do you mean efficiency, how much current does it take? Or efficiency in the sense they should produce the same light output, illumin basically, illumin. No, I'm losing it. Yeah. What else? Okay. You can only compare like for like. Illumin power should be the same. In life cycle costing or any other business, you can only compare like for like. You should only compare like for like. There's a wording for it. We'll come to that wording in a minute. But I would say there's one more step, critical step. You bought it for a certain life. It gives you operational savings during that life. It gives you the same output. Great. What happens at the end of it? How do you dispose CFL? How do you dispose tungsten bulb? Chuck it out and hopefully it'll disintegrate. A tungsten bulb is a bit more easier to dispose of because it just have the glass and the metal part of it. So the metal part of it can be recycled if desired. CFL is a bit more trickier than that. It does have electronic parts in it as well. And it might have, I don't know what the powder is, very likely it might have mercury powders in it. So it's a bit more tricky recycling it. So there will be a cost of recycling. But at the moment that cost is borne by the government. And that's why they're promoting CFL all the time on the agreement that they will take it back and they will recycle it. You might dispute that it's not happening, but that's the intention. So okay, so these are the aspects that you have in taking that decision. And one strand of it is the cost, and the other strand of it is the energy or carbon emissions. Okay, so these are two strands that we can use. We're now going to focus on the cost. So CFL and tungsten bulb, which produces the same illumin output, therefore they're like for like, have these two, this is the wattage, the requirement for energy. So tungsten needs 60 watt, equivalent light can be produced by a CFL at 11 watt. The service life for CFL is higher because apparently they'll last longer. Okay, but the initial cost is high. It's in pounds, but I'm sure you can convert. Cost of electricity is also given. Can you calculate the life cycle cost of CFL and tungsten and tell me which choice is better and also by what measure they are better? Quantitatively. Qualitatively, you know, you can say that this is better. That's the gut feeling. But what I'm asking is beyond the gut feeling, what is the actual figure? That CFL costs this much compared to tungsten costs this much over service life. So you'll need to bring the service life to be the same for both cases. Without that you can't compare. Okay? Which means you'll need to keep buying this. So it gets trickier. So draw a line and identify 10,000 hours using just markings and figure out how many tungsten bulbs you have to buy to reach the 10,000. Do we have agreement that it's 10? I'm not saying anything. I'm not disputing it either. Draw it out and then figure it out. And then just do the calculation and tell me what the 60 tungsten is 60 times more expensive. Is that what you say? Or I'm open for others to do the calculation as well and tell me the total figure. How did you get 60? Hours, okay, but I may need to buy a number of bulbs to make it last. So for 10,000 hours at 11 watt per hour, and that's the cost of electricity alone. Okay, so for CFL, that will be 11 watt per hour times 10,000 hours. Times 0.1 kilowatt hour. Okay. So this would give you, that means you'll use 1 0 there. So how much is it? So this is kilowatt hour, okay? So you'll need to divide that by 1,000. Okay. So that means 11 pound. Okay. That's what the operational cost of CFL is. Tungsten will be just exactly the same, except that'll be 60, okay? 60 times 10,000 times 0.1 divided by 1,000, which is 60. So even at operational cost, tungsten is nearly 5 something times more expensive. Added to that, this needs one bulb. Yeah? So altogether this would be 14 pounds for the 10,000 hours. Do you agree? So I have not, this is only the operational savings of it. To that I need to add the replacements. Okay, I'm coming to the replacement in a minute. So here now I've added the replacement or the bulb needed. So this is the total cost for CFL. Okay, so to that 60, now I need to add the replacement cost. How many bulbs do I need to go to 10,000? I need 10 bulbs, okay? So that's 10. Okay, so that's 5. Okay, so this will be 65 pounds in total. Do you understand? Do you agree? Okay. So clearly now you have a figure of whichever one is the more costly option. Okay, is it 4 point something? I just gave only a representation of it. Any questions? We have not. In this case, we have not said anything about recycling cost. I'm just assuming that I'm going to throw the bulb away. But there are wordings for all of these life cycle exercises, okay? If the life cycle exercise is from cradle to site or cradle to gate means it's normally used for manufacturers. They dig it out of the ground, they make the product, they bring it to their gate, not your gate, their gate. That's the boundary that they're going to define. And what happens after is your problem, not theirs. So all these operational savings will now be in it because that's what happens after the gate. So if somebody says the embodied carbon is such and our embodied carbon is extremely low, watch out on what the small print says. Does it say cradle to gate quite often it says cradle to site, which includes transportation. Okay, let's say you bought product A from Mangalore and product B comes from China, and product B is claiming to be efficient, which could be, technology could be evolved, but when you say cradle to site, it might have to come all the way from there to here, and that component might be higher. Okay, so that gives you like for like comparison. And there's another evolution of it. So cradle to gate started earlier, cradle to site came next. Now the next thing is called cradle to cradle. Okay, that includes full recycling and everything. That's normally used by people like government or companies that are responsible for recalling the products and putting it back. You might wonder who does that. In the future, your cars will be owned by yourself but not the battery. You will own the car but you won't own the battery. The battery will be on lease. So you drive, you finish the use of the car, you return the battery back to the manufacturer. There might be some form of incentive for you to return, and they can reset the battery and put it back again. Okay. Lithium ion batteries are expensive, and that's what's been used